Okay, so we're doing linear and piecewise functions. So quick review of lines. Writing the equation of a line, we've got a couple different ways we can go about it. For the first one, if you know what the slope m is and the y-intercept b, how can we put that into the equation of a line? Y equals mx plus b. Okay, what is the name of that form? This one is slope-intercept form. So slope-intercept form. Okay. Now, if you're given a slope and a point, we can use another form. That would be the point slope form. And what does that one look like? Alright, so we're just going to do y minus y1 equals m x minus x1. Okay. The other situation is we could have 2 points that are given, and then we've got to put it into an equation. So if we have 2 points and we already know that it's going to form a line, what's the first thing we should find? Find the slope. All right. And so to find the slope, we can either do y2 minus y1 over x2 minus x1. So again, change in y over change in x. Or could we also do y1 minus y2? x1 minus x2? Yes. So it doesn't matter the order that you do it in, you just have to make sure that the corresponding pieces are coming from the same coordinate.
And what is this form called?
Well, this is, at this point, we found the slope, and now we can use the slope to put it into either of the equations above. The easiest thing is to, because we already have points given, the easiest thing is to use the point slope form. Here. Or, again, it doesn't matter which format you use, which point you use, which coordinate. So we could also have used the y2, x2 as well. Okay, both of those are valid. Okay. If we wanted to put it into slope-intercept form, we'd have to do a little bit of arithmetic to figure out what the y-intercept is. So usually these are the easier ones. They require less work. The only work really is in finding what the slope is. All right. So in our first one here, we're going to find the equation of the line with the given values. We've got f of 4 is equal to -2 and f of 8 equals 4. What is that telling us? 2 points. So when it says f of 4 equals -2, what does that mean? Okay. When x is 4, y is -2. So this is just the coordinate for -2, which means the other one is just the coordinate 8, 4. All right. So again, we have 2 points, and so we need to find the slope between them. So, and again, doesn't matter which one we do first. Which one do you want to put in the front? The first one? Okay. So we get -2 minus 4 all over 4 minus 8, which gives us -6 over -4. And what does that simplify to? 3 over 2. Okay, so we know that the slope is 3 over 2, and we just want to put it into an equation of a line. The most straightforward way is to pick one of those coordinates. Which coordinate do you want to use? The first one? Okay, so we would have to do y minus -2 is equal to 3/2 x minus 4. And then I don't want to leave that double negative in there, so I'm just going to turn that into y plus 2 is equal to 3/2 x minus 4. Is that a valid equation of a line?
Yes.
It is. Okay. And did we really have to do any more calculating? No. Okay. So if you're not asked for a specific form and you have a point and a slope, this is going to be the most straightforward way to do this. Now, can we turn this one into a slope-intercept?
Yes.
Yeah, what do we have to do? Yeah, we're going to have to distribute. So this would become y plus 2 is equal to 3/2 x minus 12 over 2 is 4. Oh, sorry. 12 over 2 is not 4.
Wait, M is the same thing as y, right?
What's that?
M is the same thing as y.
No, m is the slope. The term that's attached to the x.
It is 4 eventually.
What's, oh, the y-intercept.
No. You put 4 the first time, and I said it is 4. Oh no, it is 4 in the end, but...
Okay, in the end. So I still have to isolate the y, so I have to subtract the 2. So we get y is equal to 3/2 x minus 4.
It's 8.
Wait, it's 8.
8! Oh my gosh, what is wrong with me, y'all? Just kidding. I was just testing to see if you're paying attention, all right? Good job, everybody. Okay, so now we've put the equation into slope-intercept form, but as we just saw, what's the risk? Arithmetic error. I just made 2 of them just in transferring it. So I took a correct equation that was perfectly valid, and I made 2 arithmetic errors correcting it, or trying to turn it into another form. So again, if you don't have to put it into a specific form, I would always go with the most straightforward one. Okay. All right, is that the only way to find the slope-intercept form? No. Okay, so we have another way. We could start with the y is equal to mx plus b. We already know that m is going to be 3/2, and again, we can just pick either of those points. I would go with the 8, 4 just because they're both positive. So I'd plug in y is equal to 4, m is equal to 3/2, x is equal to 8 plus b. All right. In the end, we solve for b. We get 4 is equal to 12 plus b. So what does b equal?
-8.
-8. So did we get to the same place? Yes. Again, we had to do some solving here. So again, you're running the risk of possibly making an arithmetic error. Yes, Amber?
Oh wait, never mind.
Okay, so I'm going to let you guys do B. You're welcome to go work up on the board if you'd like, work with a partner, and then we'll compare our answers. Alrighty. Who would like to share a solution? Ava. Yes, okay, what'd you get?
I got y minus 2 equals -2.
Okay, anybody else do this one?
Wait, what is that in slope intercept?
This is point slope. So she used the first point, 1, 2. So there's the minus the 1, minus the 2, and the slope is -2. Somebody do the other point? Yeah. What did you get?
Y equals -2x plus 2.
Is it plus 2?
Not plus 4.
Should be plus 4. Y equals -2x plus 4. So just double check your arithmetic. So again, well, it happens. You guys watched me do it twice. Okay. And one more. Do you have another one?
Oh no.
No?
I was just gonna ask a question.
Okay. You have the other one?
Y plus 2 equals -x 2 open x.
2x minus 3. Okay, so All three of those are valid. All right, you had another question?
Oh, my question.
Uh-huh.
Yeah, so are we required to use all three of them?
No.
So we can just
You need to pick one, yes.
For all the problems that we have like that, can we just pick our favorite
Yeah,
one?
you just have to pick one, unless it's specified, put it in this form.
So
Yeah.
we will have to use the other ones if we don't.
Possibly, yeah. So if you're asked for a specific form, you need to give the specific form. But if you're not asked, do the one that's the least work, where you're, least likely to make an arithmetic error.
Did we have to simplify the 2? Because originally I got negative 4 over 2, which is the same as negative 2.
Yeah.
But generally I like to keep it because slope is negative 2.
Well, it's the same thing as, well, even if you have a slope of this, it still means that the rise is negative 2 and the run is 1. Yeah, so it's the same thing. So you want to simplify.
Okay.
Yes. Yes, Elle?
Never mind.
Okay. All right. So let's look at the next one. We want to write the equation of the line that contains the point 3, negative 4 and is perpendicular to the line 2x minus y equals 3. So the first thing, if I need to find a line, but it's perpendicular to another line, what do I have to know about the original line? Were you raising your hand, Charlie?
Yeah.
Yes? Okay. The slope. Okay. So if I have 2x minus y equals negative 3, what do I need to do to find the slope of that line? Is it Maddie? Yes.
Put it in slope.
Slope-intercept form. Okay, so that means isolate the y. I have a minus y here, so I'm going to move this to the other side. So y is equal to 2x plus 3. Are we now in slope-intercept form? Okay, what is the slope of this line?
2.
Slope of this line is 2. Okay, but I want a line that's perpendicular to this. So how do we find a perpendicular? Is it Jaina?
Yes.
Okay.
The slope is. Wait, I forget what it's called. Oh, the negative reciprocal.
Negative reciprocal. Okay, so I'm going to do perpendicular slope is. So if my original equation has a slope of 2, the negative reciprocal would be negative 1/2. Okay, I have the slope, I have a point. What's going to be the most straightforward equation to use? Point slope form, right? Y minus negative 4 becomes y plus 4 is equal to negative 1/2 x minus 3. I didn't have to do any more work. It's correct. But if I wanted or needed to turn it into slope-intercept form, can we do that pretty easily? Yes.
So we can leave it like that. We don't have to do, unless like it tells us we can't.
Yes, unless you're told to specifically put it into either standard form or slope-intercept form. But this is perfectly fine like this. Standard form would be this one up here.
Oh,
Yeah.
oh, with all the variables on it.
Yes, that's standard form. Okay.
Oh, I have all the variables on one side.
Yes. Okay. I'm going to let you guys do the next one. Still looking for the equation of a line. We want to go through the point 3, negative 1. However, this time parallel to the given line. And again, feel free to work with your neighbors. All right. So what did we find for the slope of this one? Did you get it?
3
3
halves.
halves. Okay. So when you solve this one, we should end up with 2y is equal to 3x minus 4. When we divide by the 2, 3 halves x minus 2. And so yes, slope is 3 halves. Parallel lines have the same slope. So again, we can leave this as y plus 1 is equal to 3/2 x minus 3. Okay. Did anybody put this into slope-intercept form? Nope, didn't mess with it. It's just more work. Right. Okay. You did? Okay.
I had y equals 3/2 x minus 3.
Okay. So if you do this though, did you make sure that you distributed that to both terms on the inside?
I did that too, and I
Got the same answer?
subtract the one after.
Okay, so let's look at this. This would be y plus 1 is equal to 3/2 x minus what? What's 3/2 times negative 3? You guys did the same thing? So it would be minus 9/2. Yeah, yes. And then we'd have to subtract that 2/2.
So would it be minus 3 minus...
Just leave it as an improper fraction. Negative 9/2 minus 2/2.
7/2.
Oh, minus. They're both negatives. So 11/2. All right. So again, you have to be careful if you're going to convert it or solve. Did you have another question, Paulina? No? Okay. All right, so let's look at our piecewise functions. Okay, we've got a graph here. This one's not on the handout that I passed it out, so you'll just have to look up on the board. Okay, so take a look at this one up here and go through the questions on the side and discuss with your table mates, your partners, and see what you come up with. Okay, so it's just another term. So remember, whenever you use like function notation, the function of is the input, right? So the input that we're talking about here is the x's. Yeah. So is this function y a function of x? Right, x is input and y is the output.
How would you know if it was?
Well, so it's marked on the graph. We have x's over here and y's over here. The big question is does this represent a function?
No.
No?
Wait, yes.
Yes, why?
Passes the vertical line.
Yeah, passes a vertical line test. So again, if we have a graphic display, then the vertical line test is a great method for testing if it's a function.
Can it not be a function even if it passes vertical line test? Like, can something be like not a function? It's still pass the...
No, it has to pass the vertical line test.
No, that's not what I'm asking. I'm asking, okay, so you got this line thingy that passes the vertical line test. Can it not be a function? Is there a possibility of it not being a function even though it passes?
I can't think of a counterexample. Yeah, I can't think of a counterexample. Yeah, because the whole thing is about one input to one output. And so as long as you can come up with some sort of a representation of that relation, then...
Like, is there any more criteria that it could not pass that would make it not a function?
That would make it not a function.
It would only be if the graph was blank.
Yeah, I can't think of a counterexample. But if anybody comes up with one, please share it. Question, Al?
What's the vertical line test?
Okay, so we would take a vertical line. Let me just draw one here. Okay, and then we run it across the function. And it should only touch the function how many times? One.
Or 0 times.
Well, then you don't have a graph, right? Okay. All right, so what's happening right here at x equals 0?
It's still only touching once.
It's still only touching 1. And how do we tell?
Because of empty dot.
Yeah, because we have an open circle here and a closed circle here. So Again, does it only touch the function in one place? And it does each time. Okay. All right. Okay, well that kind of leads us to the next question. What's the value of the function when x is equal to 0?
0.
It is 0. Okay, and again, we can tell because what's going on at the 2.
The bubble is not filled in.
Yeah, it's not filled in. So 0, 0 has a solid circle. Okay. All right. So the next part is breaking it down and finding the equation of each of the pieces. This first one is asking when x is less than or equal to 0. So is that the left-hand side or the right-hand side? It's the left-hand side. What's the slope? -1. So that's just going to be negative x. What's the y-intercept? 0. So we don't have to put anything in. Okay. How about the other one? When x is greater than 0, what's our equation?
2.
Just 2. All right. So again, we just look at the individual pieces of the function, and then we write an equation to represent each piece, and then we have to specify the domain. So again, any piecewise function is made up of 2 or more equations. Do you have a question, Jada? Oh, yeah. Okay, so when we write these down, we write it down in one function. So this one is called f of x is equal to, and then we create a bar to sort of, not a bar, but like a curly bracket to enclose our equations together, and then we just put them in order. Our first one we said was negative x, and we said that was valid for x is less than or equal to 0. So that's the domain of that piece. And then our other equation, it's 2, and that one has a domain of x greater than 0. And so that's all we have to do to write down the function. So each piece. All right, so our next part here, we're going to evaluate. So again, what does it mean to evaluate a function? Solve it, right? We're plugging in an x and we're finding the y that goes with it. So for these, we have to pay attention to the domain. So in this equation where I've got f of x equals 3, if x is less than -2, I have x plus 2 if x is between -2 and 5, and 4x when x is greater than 5. Yeah. This way?
Yes.
The other way. This way?
Yes, ma'am.
Okay. All right, so for this one, how many pieces is the function in? It's in 3 pieces, okay? So we want to pay attention to the domains when we go to evaluate. Our first one in A is asking for f of -8. -8 falls in the domain of which of those pieces? Okay, falls into the first one over here. So we just plug -8 in here, except there's nothing to plug in because it's just 3. So f of 8 is equal to, or sorry, -8 is equal to 3. Right. Then we have f of -2. -2 falls in which of the domains? In the middle one. So this one, we actually have a variable in the equation, so we're going to plug it in. So replace x with -2 plus 2. So that means that f of -2 is equal to 0. So in C, we have f of 0. So 0 falls in which domain? The second one again. So we're going to replace x with 0. So we get 0 plus 2. F of 0 is 2. All right. Our next one is f of 3. 3 falls in which of the domains? The second one again, so going to replace x with 3. plus 2, f of 3 is equal to 5. All right. F of 5. 5 falls in which domain again? Second one again. So it becomes 5 plus 2 is equal to 7. And how do we know it's in the second one and not the third one?
The equal to.
The equal to. Okay. And then finally we have f of 10. Question, Ava? Yeah. So that one's going to fall into which domain? The last one. So this becomes 4 times 10. So f of 10 is 40. Okay, so how do we feel about evaluating piecewise? Okay, yeah, these are not bad. Okay, so now we're going to actually graph a couple piecewise.
Oh, fun.
Okay, so our first one, x plus 1 for x less than or equal to 0, and negative x for x greater than 0. And let me try to... Okay, this thing is so finicky. Hopefully it will go in straight for me. Okay, I think it's going in. It sort of drives me crazy when it doesn't stay on the lines. Okay, all right. So we're going to look at the first one. I'll do that one in purple here. Okay, so the equation is x plus 1, but it's for all values of x that are less than or equal to 0. So again, I can look at this. It's a linear function. The y-intercept is at 1. So let me mark that there. And it has a slope of positive 1, which means if I were to graph the entire piece of the line, it would be doing something like this. However, which portion of this line am I interested in?
Less than.
The less than or equal to. Okay, so since it's a less than or equal to, I am going to make my point here a solid circle, and I'm only going to graph the left-hand side of this. So now I'm going to look at the other piece. The other piece is negative x, but only for x is greater than 0. So I need to look at the y-intercept, which is 0. And let me mark that. And we have a slope of negative 1. So if I were to graph the whole line, I would have something like this over here. But again, which piece am I interested in? Only greater than, so only the piece to the right. And since this is a greater than 0, I want to make sure I have an open circle here, and I'm only going to graph this portion. Yes.
Can I use the rest?
Yeah. Okay, so let's talk about domain and range now that we have it graphed. Domain, x values. Any restrictions on x?
No.
Nope. So we could either say x is all real numbers, or we could do interval notation. Okay. And how about range?
Y is less than
Okay.
less than 0.
Less than, would it be 0?
Less than or equal to 1.
Less than or equal to 1, yes, because we have the highest y value we have is positive 1. Or as interval notation, we would have negative infinity to 1 inclusive.
So we can do whichever.
Unless it specifies. Yeah, you can do either one. Okay. All right, so what do we think of those? All right, so if you get mixed up, please remember you always have the option of doing an XY table. All right, so we could say for the first one, I could make an XY table. The input is X and the output is X plus 1. And what would be the only values I would plug into this one? Would I want to solve this one for x equals 2?
No.
No.
It's less than.
Yes, because I only am interested in the values that are less than or equal to 0. So again, that's an option. So I could try -2 if I wanted. And you would want to go ahead and plug in that 0, just because that's where the change is occurring. So you always want to check that beginning or end point that you have. Okay, let's look at the next one. Get a graph in here. That one. No, I think I took it off. Okay, here we go. Let's see if the second one works out for me. Yes, there it goes. All right. So again, we have a change occurring at 0. And so for the first one, x minus 2, so we have a y-intercept of -2 and a slope of +1. So again, it would do something like this, but we're only interested in the left-hand side of 0. And it's a less than, not a less than or equal to, so we put an open circle there, and we just graph that side. So that's the blue line. And then for the next one, 4x, so y-intercept of 0 and a slope of 4. Okay, and the steeper the slope, the harder it is for me to draw a reasonably straight line. So we'll see how this goes. Okay, so it's sort of a line going that way. Okay, and this one is a greater than or equal to, so I would want to go ahead and make sure I have a solid circle there. All right.
Is it up 4/1?
Yes, up 4/1. Okay, so domain and range again. Any restrictions on x? Nope, so we can do -infinity to +infinity. And what happened with our range this time?
There's a break.
There's a break. So how would we want to write this? Yeah, let's put a union in. So what's the first interval going to be? -infinity. So remember, it's going down forever in this direction. So we have a -infinity. And then continues until it reaches -2. And is that -2 included or not? Not. So we put a soft bracket. Union, and then we pick up again where? Pick up again at 0. Is that 0 included?
Yes.
Yes. And goes on until +infinity. Do you have a question, Maddie? Yeah. Okay. How do we feel about graphing the piecewise? You okay? Okay. All right. Just remember, if all else fails, make an XY table and plug in a couple values. Okay. The last one is writing the equation for the piecewise based upon the graph. And you guys should have this one on your sheet that I gave you. Okay. So I'm going to look at the first one here. My graph is in 2 pieces. So I'm going to set this up as f of x is equal to, and I'm just going to make my curly bracket big enough for 2 equations. Okay, and always start left to right. So if I look at the leftmost equation, what's my slope? Is it 1? -1. Right, it's going downward, so we get a -x. Y-intercept is -1. So -x minus 1, and this is valid if x is
Less than or equal to 0.
less than or equal to 0. Okay. And then our other one, what's our slope? 1, so we get x, and this time our y-intercept is 2, so we get x plus 2, and this one is valid for which values? X greater than 0.
Wait. Can be greater than 2?
We're looking at the x values, and so this is at x equals 0 here is where the change is occurring. Okay, last one. Is everybody getting like antsy and hungry?
Yes.
I'm tired.
The lights are off and your voice is very calm, so I'm like,
Oh, my voice is calm?
yeah, it's calming. Yeah, it's calming.
Is that a good thing or a bad thing?
It's very
I
good.
don't
It's
know.
good except for whenever you're really sleepy and the lights are off and you're just like,
Okay, so we'll get through this last one.
yeah.
That will be okay. All right, how many pieces are we in? 3. So I want to make my curly bracket just a little bit bigger. All right. So this one is a little bit trickier because 2 of our lines are not crossing our y-intercept. However, we can project. So if I look at the first piece, what is my slope? -1. So we get negative x here. And again, it's not actually crossing, but we can sort of project that it would go to -2. So we get negative x minus 2. And that's going to be for which values of x?
Is less than or equal to
X is less than or equal to -2. Okay. Does anybody have any questions on where we got that part?
No.
All right. Okay, we've got a middle equation now. What is that?
X equals 2.
It's just 2. What is the slope of that line?
0.
It's 0. Exactly. So there's nothing to multiply by the x. So we got 2. It crosses y equals 2 here.
So that's
Okay. So that means what values of x are we valid for?
Greater than -2.
Greater than -2 and less than 1. Sorry, it's kind of squeezed in there. Okay, one more and we're done. Can we do it?
Yes.
All right, what's the equation? 2x minus 3.
Wait, where'd you get the -3?
So we're going to continue with that slope of 2, and we see that it continues to -3.
X is greater than or equal to 1.
Greater than or equal to 1. Beautiful. How are we feeling about these? Pretty good. Okay, there's 2 more on your on that little handout that I gave you, so you are welcome to practice those. The PDF of this is already posted, so if you want to look back and check for extra practice, you can. And otherwise, that's all we have today.